Okay, we're starting a unit on logs and exponential functions. So first thing we want to approach is exponential graphing. And what exponential graphing shows us is a growth or a decay of some value. And we're going to work through this just algebraically today, and we'll make it real world application tomorrow. All right, so let's just look at this problem. Here it is, y equals 3 to the x power. This makes it exponential because it's an exponent. So when you graph these today, we're going to set up tables just like this, okay? And our x values are all going to be the same. We're going to go -1, 0, and 1. And we're going to plug that value into where x is, just like normal. So 3 to the -1 power. Now, you may not remember this. With exponents, if you have a negative exponent, what that will do, 3 to the -1 power, makes it 1 over 3. Notice the 3 is not negative. It just put that negative in the denominator. So 3 to the -1 power just makes it 1 over 3. Okay, so 1/3 is my y. 3 to the 0 power. Okay, remember anything to the 0 power is always just 1. Doesn't matter if it's a huge number. If it's to the 0 power, it's a 1. So y is 1. 1 and 3 to the first power, well, that's just 3. Okay, so if I graph these points, at -1 I have 1/3. So that's just barely above my axis. At 0 it's at 1, and at 1 it's at 3. Okay, so my curve is doing this shape right here. And it continues on here. Does not cross the x-axis because it's not going to be negative. Okay, now, that being said, let's just move on to the next one. Look at this one. This one has 4 times 2 to the x. So it could have been written like this, or you could have parentheses around it. It doesn't matter. It's the same idea. But I'm going to show you how it affects your answer. Like we said before, our x values are going to be -1, 0, and 1. Now to work it out, I'm going to do 4 times 2 to the -1 power. Remember that negative power makes it a fraction, so it becomes 4 times 1/2. Okay, just puts that 2 in the denominator. So 4 times 1/2 is just 2. 4 times 2 to the 0 power. Well, 0, anything to the 0 power we said is 1. So it's 4 times 1. That gives me 4. 4 times 2 to the first power. Well, that's 4 times 2, which is going to be 8. All right, I've got my 3 points. At -1, I'm at +2. At 0, I'm at 4. And at 1, I'm at 8. 6, 7, 8. All right, so my curve is doing this. Okay, now, just look at this for a moment. Where x was 0, y is 4. Notice 4 is the coefficient right here. Yes? Okay, where x is 0, y is that coefficient. Let's look back at the problem we just did. Where x is 0, y was 1. Well, if I put parentheses around there, isn't there an unwritten 1 right there, if you think about it? That's where that 1 comes from. All right, let's just see if the pattern continues. Let's try this one. Okay, y equals 1/3 to the x power. Okay, so -1, 0, and 1. So I do 1/3 to the -1 power. Okay, so what happens when a fraction is raised to the -1 power? Well, what's in the denominator becomes the numerator. It just flips it. Okay, so it would become a +3. It's not -3, it becomes +3. The negative power flips the fraction. So this is +3. 1/3 to the 0 power. We said anything to the 0 power is just a 1. And then 1/3 to the first power. Well, that's just 1/3. Okay, so -1, I'm at 3. 1, 2, 3. At 0, I'm at 1. And at 1, I'm at 1/3. So notice this curve. From left to right, it's getting closer and closer to 0. So this is what we would call a decay graph. It's getting smaller left to right, right? Like this one, a -2 leading coefficient and 1/4 to the x power. So -1, 0, and 1. Let's plug in our values. -2. Okay, so again, a negative exponent is going to flip my fractions. So it's -2 times 4, which gives me -8. -2 to the 1/4 to the 0 power. Well, that's -2 times 1, which is -2. and then to the first power, negative 2 times 1/4 to the first power. Well, that's negative 1/2. Okay, so if I plot my points, negative 1 times negative 8, 0, negative 2, and 1, negative 1/2. Okay, so my curve is doing this. Okay, but notice something. Where x is 0, y is negative 2. And where did that negative 2 come from? It's the coefficient right here. Okay, now notice this curve is from left to right is moving up, so this is a growth curve. All right, the last one we looked at was decay. The one before that, what do you think? Left to right, it's moving up, so this would make it a growth curve. Okay, and here, what's this one doing? This is also growth. Alrighty, now negative 4 to the x power. Now you need to think about it as this. Negative 1 times 4 to the x power. Pull that negative away, all right? Because it's going to affect your graph, and you want to see how. Negative 1, 0, 1, again. It's negative 1 times 4 to the negative 1 power. So it's negative 1 times 1/4. Remember that negative 1 power makes it a fraction. So that makes my answer negative 1/4. 0, negative 1 times 4 to the 0 power. Well, that becomes negative 1 times 1. That's negative 1. Negative 1 times 4 to the first power makes it negative 4. Alright, so negative 1, negative 1/4. The 0 is at negative 1, and at 1 it's at negative 4. So look at that, it's flipped over. So this graph is representing a decay of some sort. And why do you suppose that is? Well, that leading negative right there flips it over the x-axis, which makes it a decay problem. Okay? Alright, so we need to identify growth versus decay looking just at the equation. Now we graphed a bunch of these, and what we discovered was in our tables where x was 0, y was whatever was sitting right here, whatever value was there. It was negative 1 or 4, didn't matter. Whatever the equation was, when x was 0, that was our y value. Okay, you can go back and look at the tables that we just did, and you should see that that is consistent with each problem. Okay, so whatever coefficient is there, even if it's just an unwritten 1, that becomes your y-intercept. Now, whatever the base of the exponent is here, whatever is being raised to the x power, will help you know if it's a growth or decay. If that value b, we're calling it b, is greater than 1, then it's a growth curve. If it's between 0 and 1, then it's a decay curve, meaning is it a decimal or is it a fraction? That would mean a decay curve. So let's look back at our curves. So you should be able to look back at the curves that we did and see that if this was greater than 1, it was growth, and if this was less than 1, it's a decay. Now the only exception to the rule is if A is negative, it will reverse the direction. Okay, meaning like if I have y equals negative 2 times 1/4 to the x power, okay, this 1/4 would make you think, hey, that's a decay problem because it's less than 1. However, the negative 2 over here will reverse that. It's not decay, it becomes a growth because that negative reflects it over the x-axis. Okay, so that's the exception to the rule. If A is negative, it will reverse the direction of your curve. So just kind of keep that in mind. Look back at the examples we just did, and you should. So in these problems, all you're doing is identifying, is it growth or is it decay? So the basic idea is look at what's being raised to the power of x. Is it greater than 1 or less than 1? In this case, 1.63 is greater than 1, so this would be a growth curve. This one, what's being raised to the power of x? 1/3. Is that greater than 1 or less than 1? That's less than 1, so this would be a decay problem. Here, 0.65, greater than 1, less than 1. 0.65 is less than 1, that's a decay problem. And here, on 8. 17/10. Now be careful. Yes, it's a fraction, but think about what it is. It's 1 and 7/10. That's greater than 1. So this would be a growth curve. Now remember the exception to the rule I just told you. All right. Let's use this one as an example, number 7. If the problem had said -2 times 0.65 to the x power. Yes, the 0.65 is less than 1, and that would mean decay. However, this -2 leading coefficient makes it flip across the x-axis, which will create a growth curve. Okay, so make sure you kind of note that difference in your mind, because you'll be asked to identify growth or decay based on the equations today on your assignment. Now I want you to try this one on your own, and okay, I want you to try this one on your own, and we'll talk about it when we get to class. Make sure you identify before you're done, do that last step and identify, is this a growth curve or a decay? All right, we'll see you in class.